Okay, thank you. Good evening, everyone. My name is Shikha, pursuing PhD supervision of Dr. Shankar and supervision of Professor Veer Singh Kayat from Department of Chemistry, Dr. Ambedkar National Institute of Technology, Jalandhar, Punjab. The topic of presentation is synthesis of ZnO nanoparticles lies in CMC hydrogel enhanced photocatalytic of bisphenol A. Outline of my presentation includes introduction, uh, fundamental work, result, conclusion, and assessment. Let's start the introduction. First of all, nanoscience, nanotechnology, and nanomaterials. Nanoscience is the study of materials and structures from greater scale, where properties significantly from larger scale. Technology is the science of designing, producing, and manufacturing range of 1 nanometers, while materials that have one dimension in the scale range, approximately 1 to meters. The properties differ from scale properties as scale dependent properties. And here is the dominance of effect. Uh, Using nanomaterials, photocatalysis question is that why nanomaterials referred as photocatalysis? This is because the advanced surface doping with hydrogens is possible. They nature tunable band gaps, imperceptibility and stability, and their quantum effects. Method for the material synthesis include chemical methods, chemical and green method. Dealing with the green, the various green processes utilized in green synthesis in roots, leaves, bacteria, and all these contain chemicals like acids, enzymes, steroids, phenols, tannins, and flavonoids, is reducing stabilizing agent for the nanoparticles. The specific role of chemicals includes like polyphenols electrons to reduce metal ions, and terpenoids can nanoparticle surface shape stability, and glycosides solubility and aqueous medium, and in play a dual reduction and cap. While nanoparticles exhibit excellent analytic properties for avoiding the pollutants, their direct use in water treatment several critical challenges like their leaching water, agglomeration, and difficulty recovery of particles. One solution for the problem is maybe incorporation gel. Incorporation of nano and particles into polymer material, many advantages like enhanced stability of particles, improved reduced leaching, synergistic effect absorption and analysis, and enhanced bioavailability. Let's move to the experiment work. For the green of ZnMn2O4 particles, 5 ml extract and 0.5 molar zinc nitrate was added slowly to manganese nitrate under constant, followed by the addition of 0.1 molar NaOH. This resulted in the formation of brown precipitates. These precipitates were washed times with distilled water dried in the hot air muffled to get the Mn2O4 nanoparticles. Synthesis of xylem hydrogel. Amount of xylem and were dissolved in minimum amount of aqueous solution, and the whole was stirred for about minute to get homogeneous solution, followed by the addition of chlorohydrin which is a cross linker. The solution was stirred for a minute and then kept in the oven for the gelation. After 2 hours, the hydrogel this is again washed multiple to remove any residue. Uh, this is the final dry will be obtained in the in order the best hydrogel synthesis. Hydrogel was obtained against various parameters like reaction temperature and crosslinker. It claimed that the best results for the hydrogens was of for hours of reaction time, Celsius temperature, and 0.84 mole per liter of the synthesis of CZNMN2 composite. Again, equal amount of xylem CMC were made aqueous NaOH for the addition of ZNM or nanoparticles and chlorohydrin. Obtained host lead kept in hot air for 2 hours. Finally, we get the CMC ZNMN2 composite. The formed hydrogen was multiple times distilled water and dried and kept for character application work. Now moving to result and discussion. Uh, and, prepared materials were characterized using variation technique for their synthesis and properties. Uh, these represent figure A represents powder result for xylem, B represent for ZnMn2 particle, and C to xylem ZnMn2 In case of xylem, see only a single peak was observed. In case of ZnMn4, multiple peaks were observed. Obtained spectrum also align well with the pattern CST pattern number 196. In case of xylem ZnMn4 presence of characteristic of ZnMn2 nanoparticle as amorphous hump in xylem CM indicates the formation of xylem CMC ZnM composite. These are the analysis results of xylem CMC ZnM4 xylem CMC ZnM4 composite. In case of ZnM4 composite, strong vibration of 400 per current the metal oxygen metal bond. The presence of both CMC hydrogel and particles of xylem CMC for composite forms the successful fusion of ZnMn2 particles in the CMC polymeric metal. The FESM result of prepared material A corresponds to xylem CMC hydrogel, B to the ZnMn2 particle, and C will xylem CMC ZnM4 nanocomposite. In case of hydrogel, morphology was observed, while in case of particles, distorted spherical was observed. In case of ZnMn2 composite, spherical Mn2 nanoparticles can be seen clearly in the polymeric. DEF to the EDS spectrum of CMC ZnM and xylem CMC 24 nano. In case of gel, peaks for carbon were observed. In case of Mn24, peaks for manganese and oxygen observed. And in case of CMC ZnM2, along with manganese, the peaks for carbon was also observed. These observations clearly demonstrate successful formation of xylem ZnMn2 this is the size histogram for ZnMn2 nanoparticle plotted SAM image software. Observed that the average particle size ZnMn2 nanoparticle is 62.1 nanometer, which is well in the material range. These are the detailed analysis for the ZnM4 and xylem CM2 composite. The increase in the value of nanocomposites, the formation more stabilized with likelihood of or coagulation. are the band gap result for the Xylem CMC 04 composite obtained using spectrophotometer plot. It was that the have a band gap of 2 electron volt lies well in visible light as are catalyst visible light. Now move to this application. Here utilized are material the photocatalytic of bisphenol. The various sources from where the bisphenol A may leach out water includes bottles and packaging, construction materials, medical and health devices, electronic objects, safety items, papers. This leach PA can be transferred to the human body through inhalations, contact, material transmission, and the major harmful impact to the human body, including the reproductive system, liver. You know, the uh, efficiency of composite and nanoparticles for the removal of bisphenol. The degradation study optimized against parameters including concentration, pH, and dose. It observed that the best removal efficiency was observed for ppm concentration pollutant, 25 mg dose, and at it was observed that the CMC or outperformed NM204 nanometers alone. The Swenger analysis result in order to the major oxygen species responsible for the removal of phenol A. Swenger analysis was out. We have used tertiary butanol hydroxyl radicus known as side radicus Swenger, ED as host Swenger. The minimum removal observed with tertiary butanol, which indicates hydroxyl radical is the main species responsible for the degradation of bisphenol A. Superoxide alcohol plays the side role. This is a propagation pathway for removal of bisphenol A under cell. It observed that the bisphenol is broken smaller metabolism and finally change the carbon dioxide and water. Degradation was used on the basis of CMS analysis. Now moving to the part, this is a effective and green synthesis of ZN4 nanoparticles. It involves the incorporation of ZN4 nanoparticles in CMC polymer. CMC element 24 performed 24 alone, getting superior photoactivity. Axial radicals are species for removal. Removal of BPA 3% by CMC for nanocomposite hydroxylide, and there is for smaller non-products. I am grateful to my supervisor Kumar Shankar, chemistry, and advisor Professor B.S. for their support and guidance. I would like to EMF 2025 providing me an opportunity of presenting my work. I am also thankful to Dr. Professor Vinod Kumar Kanojia allowing me to research work at another. I am very to all my batchmates and other staff members. I am thankful to my friends for their support. Thank you.